Hello everybody, Adam Lusek here, and today we're going to be breaking down how to use OpenAI's new Realtime API and Advanced Voice Mode to create a voice-enabled Retrieval Augmented Generation, or RAG, assistant. Now, OpenAI's new Realtime API is something that's really cool because essentially they've finally opened up the ability to use the omnimodal capabilities of GPT-4o. And what this means is that we'll be able to do direct speech-to-speech processing and generation. Both the model will directly understand and process our audio files from our speech, and then also be able to directly generate and stream back audio files itself. This creates a seamless, low-latency conversational flow. Now, why this capability is actually super interesting is because before this, generally what people did to actually create these conversational assistants is something like this. Transcribe first down the audio as some sort of speech recognition model like Whisper, pass that text then to a language model for the inference, reasoning, and generating of a textual response, and then play that model's output using a separate text-to-speech model. The biggest downside to that approach was really the latency between actually speaking and then doing the text generation and speech generation. But now we can cut all of that out and directly process speech and directly generate a spoken response back. And on top of the reduction in latency, using their advanced voice model also means that you can include things like emotion, different emphasis, accents, and other languages being accurately spoken and responding to the user with a lot more robustness. So today I'm going to break down how I use the Realtime API to create an assistant that can do something like this.
Hey there, how can I help you with your marketing questions today?
What exactly is a search engine's results page?
A search engine results page, or SERP, is basically the page you see after you type a query into a search engine like Google.
But before we get into that, I want to answer a question that I get asked a lot. Adam, how can I learn topics like math and artificial intelligence like you have? It's really not as hard as you think with the right tools and a little bit of progress each day. Which is why I'm excited to be partnering with Brilliant for this video. Brilliant is where you can learn by doing, with thousands of interactive lessons in math, data analysis, programming, and AI. Brilliant isn't just another online platform. It's really your gateway to mastering complex concepts through engaging hands-on experiences. They take a first principles approach, ensuring you can grasp the fundamentals of any topic before building upon them. Each lesson contains interactive problem solving to get hands-on with and truly down in the details. I've always been a big proponent of learning by doing, and Brilliant is no stranger to the concept. And behind every lesson is a team of brilliant minds themselves, award-winning educators and professionals from prestigious institutions like MIT and Caltech, as well as industry leaders from Google, Microsoft, and more. Their latest courses even include topics on artificial intelligence and language models designed specifically to build real skills and develop your intuition behind them. In this, you can peek under the hood of large language models like those that power ChatGPT to understand the concepts powering today and the future's technology. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/AdamLusek or scan the QR code on screen. Or you can click on the link in the description below. You also get 20% off an annual premium subscription. Thank you, Brilliant. Now back to the video. So OpenAI's Realtime API, as they claim, enables you really to build low latency, multimodal conversational experiences. And the cool part about it is that right now you can pass in text and audio, both as input and output, as well as something that we'll be taking advantage of, tool calling or function calling. One of the important things to note is that this API is actually still in beta from OpenAI. So it's not fully ready for production level use, but it is available so that we can start messing around and building some fun stuff with it. Some of the other benefits that they explicitly state here that are part of their advanced voice mode is, as I was mentioning, this native speech-to-speech that cuts out the intermediary text. So it's very low latency, very nuanced, optimized for vocal conversations. And one of the more impressive things that they're starting to refine is actually this natural steerable voices, where they can use different inflections like laughing, whispering, and different tone directions, along with its actual voice generation, making it a lot more realistic and a lot more naturally conversational than the traditional text-to-speech models that we've seen. Now, at its core, the Realtime API is a stateful, event-based API that is in the form of a WebSocket interface. So for those of you who really enjoy building web applications and stuff with JavaScript or TypeScript, this is certainly optimized for you. But I still have some good examples using some different code that anyone should really be able to approach if you have some prior programming knowledge. But if you're unfamiliar with what WebSockets are and how these things kind of work, essentially, your application that's actually hosting your API and your code is going to take the form of some sort of server. And then what you're going to do is open up a connection to that server and maintain that connection while you are actually using your application. This allows for a bidirectional, low latency connection between your machine and the server or wherever you're hosting your application, so that what we can do is start to send bits of information back and forth, which in this case will be audio files from us speaking and then getting back audio files that are generated from the model. And so as this is a lot more complex than the traditional language model-based API, where essentially you're just sending in text and some sort of prompt and then retrieving back text, there's a lot more that actually goes into the Realtime API. So of course, I'll have all of these documents linked in the description below for those of you who are interested in digging into the nitty-gritty details. But the good thing is that OpenAI provided an example to get started quickly with understanding that we'll be taking advantage of, called their Real-Time Console. And so the Real-Time Console is what they put out as a demonstration for actually using the Realtime API. And you can see that it is very similar to my demonstration earlier in the video, because that is what it is exactly based on and using a good chunk of the code from. But they provided this lovely starting point and interface with a couple examples of how to do some function calling that also shows live the different events going on between both your client and your server, showing that WebSocket connection and everything that's being sent back and forth. One of the capabilities of the Realtime API that they highlight here is the ability to do vocal-based function calling or tool calling. If you're unfamiliar with what tool calling is in language models, I have a whole nother video that I'll put on the screen right now that you can go to if you want to check it out. But essentially, it's the ability for language models or these models that process text to be able to understand when they actually need to call some sort of other API. This is a feature that's actually been fine-tuned into the models themselves, where when you pass in a schema for an API, what the inputs are and what the expected outputs are, along with a bit of a description, what it can do is actually generate a full response schema back of the query that it wants to put into that function. So it'll get all of the arguments of your API or your tool, return them back for you to actually execute, and then you can append that tool's output to the messages that it's actually running off of so that it can get any sort of real-time context. In their example here, they have two functions. They have a get weather function that takes in a latitude and a longitude and will return back the current weather from that spot, and also a set memory function, which essentially you can insert in some text and it'll save it on a scratch pad. And so of course these function calls can be pretty much any defined function that we want. So what I wanted to do was take advantage of that and create a function that would do retrieval augmented generation, essentially be able to gather some sort of relevant context from a document and pass it in as context for the generation of this voice model. And so retrieval augmented generation is something that's been done time and time again now with text-based models of essentially being able to get relevant context by querying a vector database for chunks of a document. And from your query, it'll return the most relevant documents, which will then be used as context to generate your final response or some sort of response in a conversation. This is primarily used in the context of being able to dynamically insert relevant domain-specific information into your language model's generation to ground its response in some way. So if you've seen any of the offerings where you can actually upload a document to something like ChatGPT or Anthropic's Claude, or people talking about using RAG to make some sort of chat with a document type of application, this is essentially the same idea. So now we're going to take those same ideas and apply them back to a voice model. And so to do that, what I've done is I've gone ahead and I've forked the main OpenAI real-time console and created my own version of it that's purely optimized for doing this RAG. And so it'll have everything you need along with a Jupyter notebook to actually set up your vector database and the relevant user interface now to reflect the different retrieved documents. So let's go through how to actually use this and set it up for your own documents. The first step, of course, is going to be cloning down the repo, and you can already get a little bit of a sneak peek of what my knowledge base is actually going to become. So let's get that cloned then and open it up in your preferred code editor. So for this, I'll be using VS Code, nothing super fancy, but once you have this actually cloned down, then there are a few different files of interest that you want to look at. If you go into the source and the utils, there's the conversationconfig.js JavaScript file, and then when you go into pages, there's the console page TypeScript file here. And so of course, the first thing that we need to do is actually install all of the dependencies that OpenAI used to build the original console. So if we bring up a terminal, what we can do is actually use node package manner to install all of the dependencies with just npm I. And you'll see a lot of warnings that say that a couple things are deprecated, but that's just using some of the different versions to make sure that everything's compatible here. But once we do run that, you can see that all of the errors are good to go. And so what we can do is actually hop now over to my provided Jupyter notebook to set up the vector database. This file is just going to be under vdbsetup.ipynb here, and you can load it and use it with any of your preferred code environments, including VS Code, but I prefer the main Jupyter Notebook console, so I'll be switching over to that right now. So now that we're over in the Jupyter Notebook, what we're going to be using is actually one of my preferred vector databases, ChromaDB. And ChromaDB makes it really easy to create some lightweight vector databases for on-the-fly testing for things like this. But before we get ahead of ourselves, of course we need to think of what are we actually wanting to embed in our vector database? What is our knowledge base going to be that's going to be retrieved? And so I came up with what I thought was a little bit of an interesting scenario. I thought back to my days when I was still back in school, and I was thinking, wouldn't it be so nice to have some sort of conversational assistant that I can actually do something like upload a textbook to, and then talk back and forth with it to actually learn a subject. I am very much more of an auditory and hands-on learner myself, so being able to bounce ideas, ask sort of loose, flowy questions would be something that I think I would have greatly benefited from. Thus, the idea of putting in a textbook into my vector database and creating some sort of learning assistant was born. And to do this, I'm going to be using the Open Textbook Library. This is a website from the University of Minnesota that has all sorts of openly licensed textbooks from authors and publishers that can be freely used, adapted, downloaded, edited, distributed at absolutely no cost. So for this example, I wanted to choose a nice, fun, relevant one to me, and I chose this E-Marketing Essential Guide to Marketing in a Digital World textbook. First off, because it is a 767-page textbook, and then also because as someone who's traditionally worked in sales and marketing and advertising and media and stuff like that, marketing is a very advanced topic with a lot of specific niches and nuances. So I wanted to see if I could be able to extract some of that information from my vocal assistant, as well as just be able to have this around so that I can even ask some questions when I need to know some answers about very specific marketing topics. So with our idea of our educational textbook assistant and our knowledge base of this 700 plus page marketing textbook, let's actually pop it now into our database. And I've gone over how to set up a ChromaDB database and what vector databases are a lot more on this channel, so I'll be running through this but covering the main highlights. Essentially, we're going to be creating a persistent client, which will create a Chroma folder here where our vector database is actually going to store all of its information and sit. And we'll be creating a specific collection within that database that I am just calling VDB_collection. This VDB_collection is where we're going to embed all of the different chunks when we get to chunking our PDF into. Speaking of chunking, I'll be taking advantage of some of LangChain's different integrations with the PyMu PDF loader and chunking it with a chunk size of tokens actually. So I'll be using a recursive character text splitter to split this into chunk sizes of 800 tokens with a 400 token overlap. This is OpenAI's standard token chunk size for their Assistance API, and it's generally something that I use as a baseline. But once we run that through the entire chunking process, we will end up with a total of 904 chunks of text from this PDF. And so then, of course, as mentioned, all of those chunks are going to be embedded into our vector database using our ChromaDB instance. So this is going to take just a second to insert all 904 of those chunks in there, but should be good to go in a few minutes. And so now a few minutes in the future, all of those chunks have been added. Lovely. So now that we have everything embedded into our vector database, what we need to do is create a retrieval function and also the ability for our application to be able to actually talk to our retrieval function. And so to do that, we'll be using Fast API, which is a super nice framework and tool for actually creating super easy, simple APIs on the fly. And it's great for taking things like, very unstructured Python code like what I write, and creating a actual API that you can call from other applications. But the big idea here is that we have this function query chroma, which what it's going to do is take in the query request, which we're strictly defining as a string here, and then using chroma's regular integration to query the collection that we have, which is, of course, the only collection. It will pass in the text and return the 5 most similar texts in this dictionary format here. And so using Fast API, what we do is we add on this decorator here so that we can define the endpoint as /query. This will allow us to actually then query it as an API endpoint from our web application, which is going to be the RAG interface. And finally, once we have this very simple API defined here, we're going to be using UVcorn to just run it on a port on our computer. So starting that up, this will create and host our API here on our local machine. And what we can do is actually go to this. More specifically, we can go to the docs of this to actually see the Fast API docs. And we see that we have one callable parameter, which is our query post here, which will query chroma. And we can even try it out with the try it out. We're just going to pass in string here as our example. And when we execute it, we can see that the response is 5 of these chunks of texts that it returned from our marketing textbook to this API. So now that that's set up, it's ready to go and be called by our main application. So let's hop back over to VS Code and show where that function is actually being defined and called, and how to start our interface as well as define our prompts. And the primary integration is on line 362 here in the main console pages TypeScript file, where we're calling this add tools. And we're passing in the name, which is just going to be query_db. I kept it very loose so that you could go in and change some of these things if you needed to. And we have to add in a description. And the description is also what's going to be passed back to the model itself so that it knows what the tools can kind of do. And our description here is just queries the knowledge base stored in a vector DB to retrieve relevant and specific context. Once again, keeping this vague so that it can be adapted for any sort of demonstration. We see that it's expecting a query of type string, and we also pass in a description so that the model knows what to pass in there. And we're putting in just the query string to search the knowledge base and requiring it when the function is called. That query is then sent through to our port 8000 to the query endpoint, which if we hop back over, we can see that we are hosting our API with the query endpoint to query the database on port 8000. So that should work all nicely. And then it will, of course, return all of the relevant documents. I've got a few more things here to catch and throw errors, and also some different functions for actually updating our interface with the actual retrieved documents so that we can see what's been retrieved. But with that out of the way, what we can then move to is also now our conversation config, which is going to be our main system prompt for the vocal assistant. This is very similar to any system prompt that you've seen from a language model, where you can put in all the instructions of how you want the agent to actually ask, respond, and then also now that it's actually a voice mode, you can add in a little bit of interesting things like personality or speaking style. So to go through here, what we're actually passing through is first the system settings that the tool uses enabled. And then our instructions here are that you're an artificial intelligence agent responsible for assisting a user in discussing and educating themselves on marketing. You have access to a database filled with marketing expertise as your tool. Always retrieve relevant information from the database to get the right context to assist the user's ask. Please make sure to respond with a helpful voice via audio. Be kind, helpful, and courteous, and conversational. It is okay to ask the user questions and follow-ups. The user will always start the conversation by saying hello. Generate your responses as if they are conversational and informal. Stray away from super long, complex, structured responses, but maintain the core crucial information. And then as for personality and speaking style, I say be upbeat and genuine, like a true marketer, and speak quickly, as if excited. So you can see how, while this is similar, it is also a little bit different, because now we're not just dealing with text, we're also dealing with voice, which requires a little bit of a slight paradigm shift when thinking about actually prompting these systems. So I definitely recommend tweaking the prompt and trying out different combinations and things to see what works, what doesn't, and the different quirks that come along with using voice assistants. But with that all set, now we can actually start up our server. And so to do that, we'll also be using Node Package Manager very simply with just npm start. And doing this will open up our console here on the port 3000. And while I've already done this, it'll initially ask you for your OpenAI API key in a little pop-up here. That API key is just going to be stored on your browser's local storage. So once you clear your cache or history, it'll get rid of that. But everything's all going to be nice and secure here. Just make sure that you're, of course, as mentioned, not using any of this code in a production environment, as it could leak API keys. But now everything should actually be working together and talking to each other, and the last thing to do is actually just quit stalling and try it out. So there's two different ways that you can do this: manual with a push to talk button, or voice activity detection. Let's try it out with voice activity detection so that you can see how it can actually adapt to you speaking, realize when you're interrupting it, and change. So let's try it out.
Hey there, how can I help you with marketing today?
Can you tell me a little bit more about the relationship between marketing and sales?
Marketing and sales are closely intertwined in any business. Marketing is all about creating and satisfying demand for your product or service. It raises awareness, provides information.
Can you tell me a little bit more about search engine optimization?
Search engine optimization, or SEO, is all about improving your website's visibility in search engine results. Essentially, it's the process of optimizing your site so that search engines like Google...
But what does marketing actually do at its core?
Great question. At its core, marketing creates demand for a product or service. It raises awareness, informs potential customers.
Great. I think that's all the information I need today. Thank you.
Awesome. Glad I could help. Have a fantastic day.
So as you can see, we're now able to have very good conversational experiences with these generative models. And you could see that it was also retrieving and putting here the different retrieved documents to use as context for its responses. And it was doing this dynamically as I was actually asking about it. Some of the cool parts about this is that it's really good for different accessibility options, such as if you wanted to ask it things in a different language. Could you tell me about field marketing, but in Hindi, please?
Field marketing का मतलब होता है कि कस्टमर्स के साथ सीधे संपर्क में आकर उत्पादों या सेवाओं को प्रमोट करना.
Could you actually tell me that in Malayalam?
ഫീൽഡ് മാർക്കറ്റിംഗ് എന്നത് ഒരു മാർക്കറ്റിംഗ് തന്ത്രമാണ്. ഇതിൽ ഉൽപ്പന്നങ്ങളെയും സേവനങ്ങളെയും ഉപഭോക്താക്കളോട് നേരിട്ട് പ്രചാരം.
What about Portuguese?
Claro, o marketing de campo ou field marketing é quando as empresas...
So as you can see, using the different translation capabilities of their models that they have already, along with this advanced voice mode that can start to actually do the different inflections and accents, could really open up this possibility to a wide audience, which I think is super cool. And some of the other use cases that OpenAI has provided for the Realtime API might be something like real-time customer support agents, language learning assistants. They gave some demonstrations of a fitness and health and nutrition coach, as well as a language learning application. So it'll be super interesting to see what people build with this as this capability comes really into maturity. But one of the things to definitely be aware of is actually the cost associated to this API currently. Right now, in the middle of October, a couple weeks after this API has actually been released, the input and output pricing is a little bit as such. For text, it's still at $5 per 1 million input, $20 per 1 million output tokens, but audio itself, and similar to what we've been showing, is actually priced at $100 per 1 million tokens of input, and output is $200 per 1 million tokens. They say that this equates to approximately 6 cents per minute of audio input and a whole 24 cents per minute of audio output. So as you start to do these more advanced voice-based assistants using the Realtime API, and especially putting more and more context into them as input, it starts to get really, really pricey. And while I'm sure similar to the pricing of language models today that have dropped consistently and drastically, I'm sure that this will also follow suit, but in its nascency as it comes in this beta, it is a little bit pricey, just something to be aware of. But with all that being said, I hope you found this insightful and are excited to start building with the Realtime API yourself. I'll of course have all of the resources along with the repository that I made here linked in the description below for you to use, test around with, and try things out. If you enjoyed the video, leave a like. If you want to see more, consider subscribing. And if you've got any questions, leave them down in the comments below. Thank you and have a great day.